Okay, now we're going to draw the plan of the gear puller, bearing puller assembly. So as usual, we're going to make an assembly file. Let's first put in the first part and then we shall give it a name. So just drag this one and put it there at the base. So this is very important because this one makes the reference point for every other thing which you're going to put around here. So we leave it in the center at 0, 0 distances and we just press OK. Then I can save and I'll call it bearing puller assembly. So I just click save and then I bring in the second part. So I bring in the arm and just drag and put it there. Just drag it to a position where it is almost straight. That will be that one anyway. Just click OK. So we can close this one. We'll bring it back again just to make enough space. So we'll do J for joint and click on that edge. Turn around and click on the inner edge there. Then because I already chosen a Revolute, so it's giving me a Revolute and that is what we need then. Okay, that's the first one. To see this clearly, that's 180 degrees and I click OK. So that's the first one and that one is the joint. So I want to make another joint, duplicate this into another position together with the joint. So I go to assembly where it says duplicate with the joints and then I pick that part and I pick this edge here and I say OK. So the two parts are now there. Now I need the third one. A bit tricky now. We can do another duplicate the joint. I'll pick that one and then I pick that edge. It is now going up. So just click OK. Now I don't know whether we need this one, but let me try and make it smaller. But these are the things which you're going to do in this video. So if I go back to this joint and say edit joint, it's going to give me that snap and I don't like it facing up. So I'm going to remove this 180 degrees and put 0. And we should be able to bring it to the same position as all the others. All the three legs, all the three arms anyway, but what we need now is to link them. Because this one has a revolute, that's a revolute, that's a revolute, but everyone is moving on its own. Then we just go to motion link and we choose that one and choose that. So those two you can see they are linked and they are moving together. Press OK. Then we go again to motion link and choose that one and choose that. So the three of them are now moving together and that is what we desire. We can actually even do some small motion study. Pick that joint and it will come as a bit fast here, but you pick the motion study, you need to go to assembly and pick that motion study and you get this paper. So this is now the motion study, which shows the joint over a period. So I'm just going to pick at the end here and then type in, let's say type in 10 and click on the side. So you can see now they are moving, the jaws are moving in. And that's what basically this thing is supposed to do. Now to play this one, you need to undo it, restart, and then do this reciprocating, and then you play. See what's happening? And that's how it will be moving when it is grabbing something. And this is very important, especially when we come to drawings which are linked like T levels. After that, then we put the third part. I will open the data table again, and then bring in this part and put it there. Okay. Doesn't matter where it goes. All you need to do is press J for joint. Look for the center of this, the cylindrical center, which is around there, and then look for also the cylindrical of that one and click OK, and it will be there. And that's what it's supposed to be doing, moving around, then click OK. So ideally what we need now is that when this is turning, these ones also, we can give them some kind of a link. Doesn't make much sense, but that's how really a puller should work. That when this turns around, it tends to grip more. But you can improve on that one. But this just focus on making motion link. So if I do a motion link again here, and I link this one to that one, then they will all be able to move together. So this time if I do my motion start again, then I can be able to, if I do a motion start of that one, put like 10, then now if I try to play, all of them will move. You can see these jaws are moving in, and that one is moving in a rotational manner. So which can be tying on something, and then which ends up pulling these ones in or out. Okay, so that's just a demo for this one. So now we have finished that. What we need to put is the bolts and the nuts. So we go here where it says insert, then we say insert fastener. Then now we look for the bolts as given here. So if you look for, yours may not start like this, but what you need is to look for fasteners, and then you type in that number, which is 24014. You should be able to bring some bolts. I don't think it matters much. Choose the bolt size, which is M8. This is 40, which is already there. I will not mind so much about the length of the thread. I'll just be focused on the assembly. So you move with this one. After you do that, when your cursor is going to appear the bolt actually. So if you move this bolt and put it in a geometry which is similar to what is on here, it will tend to lock itself automatically. Okay. This one has put 2 because there are 2 holes there, but we didn't need to have one in that hole. So let's see if we can delete it. Let's try again and avoid that hole. Is 240 on 4. So that's M8. And then if it can't accept to go in only one, then me, I'll just put it there. Okay. So it's there. The bolt can be adjusted and then we just assemble it. So just do J, click on that edge, and that edge. It should be able to go in. It is gone in. Then we can get a nut, insert, fastener, the washer, sorry. So the washers, the washer is 1625. So look at the plain washer. Let's put in here. Yeah. So is 125 part 1. So it should be that one. So grab this one. Click on that one. And the washer is 8.4. So look for 8.4. It's not there. We can just put, let's just put 8. Yeah, structure 8, part number 8.4. And then we go and place it there. If you just place it anywhere on that board, it will put itself in the correct position. Same thing. We'll go back again there and then we'll get the now, and this time we'll look for the nuts. And the nut we're looking for is the hexa nut. And it is 24034 hexa nut. So I'll just choose any of these. Let me use the first one which comes. Initial material, I'm not interested in, I'll just put it there and it will just be fixed. We're more about the assembly, but not the nut itself. So now we have all the nuts inside. So what is remaining now is duplicating this in the three positions. So if we just go here where it says fasteners, and we just pick all these three, or anyway, go to create, and then you can as well get rid of this now. Let's do a circular pattern, and the objects to choose is that, and that, three of them. Axis is anywhere along here. Then you click OK, and now joint, we've already finished everything. So if you try to do your motion study again, you should be able to produce the same thing as we did last time without any problem. That is now finished. Then we need to go now and do the 2D drawing, the exploded view, and the bills of materials. And this is all part of what we need to produce in a good drawing for our T-level